Your client's LLM is great for user interactions. But what if you need consistent analysis, results regardless of which model the user connects with? We'll configure a FastMCP server to always use a specific LLM for sampling, bypassing the client entirely, so your tools get predictable, controlled responses every time. You'll see how to enforce server-side model selection while keeping the client's flexibility for everything else.
Server equals FastMCP. Name equals server-controlled sampling. Sampling handler equals OpenAI sampling handler. Default model equals GPT-4o mini. Client equals OpenAI. API key equals OS getenv. API key. Sampling handler behavior equals always. Hash always use the handler, never the client. At server tool. Async def analyze data. SDR CTX context. SDR. Hash will always use the server's configured LLM, not the client's. Result equals await CTX. Sample. Messages equals F analyze this data. Data. System prompt equals you are a data analyst. Return result text.
This demonstrates the server-controlled sampling pattern, where the backend explicitly manages LLM interactions rather than delegating to client-provided models. The key concept is centralized control over text generation, ensuring consistent model usage, predictable behavior, and decoupling from client capabilities. What makes this distinctive is the ability to enforce a specific LLM provider for all sampling requests, regardless of client configuration. The pattern works by intercepting sampling requests at the server level and routing them through a configured handler, completely bypassing the client's LLM. This creates a clear separation between tool logic and text generation, where tools declare their intent through CTX. Sample calls while the server determines how, and where those requests execute. The declarative approach means tools remain agnostic to the underlying LLM provider, making them more portable and maintainable. This approach matters when you need deterministic behavior across different clients or want to consolidate LLM usage for cost, compliance, or quality control. It solves the problem of inconsistent results that arise when clients use different models or configurations. The trade-off is reduced flexibility for clients that might prefer their own LLM, but the benefit is complete control over text generation quality and characteristics. Use this when you need to enforce specific model behaviors, audit all LLM interactions, or guarantee consistent outputs regardless of client capabilities. Let's break it down line by line.
Server equals FastMCP.
This instantiates the core FastMCP server, the central orchestrator for AI callable tools. It handles routing, authentication, and execution of all registered tools while managing the connection lifecycle.
Name equals server-controlled sampling.
This names the FastMCP server instance, identifying it in logs and monitoring tools. The descriptive name helps distinguish this server when multiple instances run concurrently, critical for debugging and operational visibility.
Sampling handler equals OpenAI sampling handler.
This configures the sampling handler that determines which LLM executes requests. By specifying OpenAI sampling handler, we enforce that all sampling operations route through OpenAI's API, eliminating client-side model variability.
Default model equals GPT-4o mini.
Sets the default LLM model to GPT-4o mini for all sampling operations. This ensures consistent behavior across the server, preventing clients from overriding the model choice. Eliminates configuration drift by enforcing a single model version.
Client equals OpenAI. API key equals OS getenv. API key.
This initializes the OpenAI client with the API key from environment variables. Environment variables prevent hardcoding secrets, and OS getenv handles missing keys gracefully by returning none if the key isn't set. This is the standard pattern for secure credential management in production systems. This closes the OpenAI sampling handler configuration block. It finalizes the sampling handler setup with the specified model and client, ensuring all subsequent AI calls use this exact configuration.
Sampling handler behavior equals always. Hash always use the handler, never the client.
This enforces server-side sampling control, eliminating client-side model overrides. By setting sampling handler behavior equals always, you guarantee all sampling requests route through the configured OpenAI sampling handler, preventing inconsistent model usage across tools, critical for production systems where model consistency matters. This closing parenthesis terminates the FastMCP server configuration block. It finalizes the server instance with the specified sampling handler and behavior settings, making it ready for tool registration.
At server tool, async def analyze data, SDR CTX, context, SDR.
This decorator exposes analyze data as an AI callable tool in FastMCP. The CTX context parameter is mandatory for all FastMCP tools, providing access to sampling, logging, and progress reporting. The async definition enables non-blocking LLM calls through the server's configured handler.
Hash will always use the server's configured LLM, not the client's. Result equals await CTX, sample.
This calls the server's sampling handler via the context object, enforcing the server-controlled LLM configuration. It defeats client-side model overrides, ensuring consistent behavior across all tool calls. The await CTX sample pattern is FastMCP's standard way to trigger LLM sampling with full server control.
Messages equals F analyze this data.
This constructs the prompt message sent to the LLM, combining the input data with a clear instruction. The F string dynamically inserts the data parameter into the prompt template, ensuring the LLM receives both the raw data and explicit analysis instructions in a single message.
System prompt equals you are a data analyst.
This sets the system prompt for the LLM, defining its role as a data analyst. It ensures consistent behavior by providing explicit context before every sampling call, eliminating ambiguous responses. This is the standard pattern for role specialization in LLM interactions. This closing parenthesis terminates the FastMCP server configuration block. It finalizes the setup with the specified sampling handler and behavior, making the server ready for tool registration.
Return result text.
This extracts the raw text response from the LLM result object. FastMCP sampling always returns a structured result containing metadata, but tools typically only need the generated text output. Server-controlled sampling pattern. The sampling handler behavior equals always. Configuration demonstrates FastMCP's ability to enforce centralized LLM control, bypassing client-side sampling entirely. This mode silently overrides any client-provided sampling capabilities, which can mask client-side LLM integration issues during development. Use this when you need deterministic LLM behavior regardless of client implementation.
The handler that takes all choices makes every choice possible.